Scientists are careful people, methodical, precise, deliberate with language. They spend careers choosing exact words for exact things. They argue over terminology in academic journals. They debate naming conventions in peer-reviewed papers. So when a group of professional marine biologists, people who study ocean life for a living, looked at a tray-specific creature pulled from the deep ocean and decided to name it Vampyroteuthis infernalis, that means something. Because Vampyroteuthis infernalis translates directly from Latin as the vampire squid from hell. Not informally, not as a nickname. That is its actual, official, peer-reviewed, internationally recognized scientific name. The vampire squid from hell. And here is the thing, the scientists who named it were not being dramatic. They were not trying to generate attention. They were being accurate. Because once you understand what this animal actually is, where it lives, how it survives, what it does, how it evolved, you realize that name is not sensational at all. It is just a description, an honest, clinical, scientific description of something genuinely unlike anything else alive. The vampire squid was first formally described in 1903 by German marine biologist Carl Chun. Chun was leading an expedition to the Valdivia expedition, one of the earliest systematic deep ocean research voyages in scientific history. The team was cataloging deep sea life across multiple ocean basins, and then they brought up something that did not fit. It looked like a squid, somewhat. It had 8 arms like an octopus. It had 2 long retractile filaments more like a squid. Its arms were connected by a dark webbed cloak unlike either. Its skin was deep red to black, almost no pigmentation variation. Its eyes are disproportionately enormous. And when Chun tried to classify it, he ran into a fundamental problem. It was not a squid. It was not an octopus. It was not any known cephalopod category. It occupied its own order, Vampyromorpha, sitting between the octopuses and the squids on the evolutionary tree, sharing characteristics of both without being fully either. A biological category of one species, one genus, one family, one order, entirely alone in its classification. That taxonomic isolation reflects something real about this animal. It is not a variation on a familiar theme. It is something that evolved along its own path, diverging from the common ancestor of octopuses and squids somewhere between 200 and 300 million years ago, and has been refining that independent path ever since. The dinosaurs came and went during that time. The vampire squid kept going, alone in its category, in the dark. To understand the vampire squid, you need to understand where it lives, because where it lives is not simply deep ocean. It is a specific layer of the deep ocean that most marine life actively avoids. The oxygen minimum zone, between approximately 600 and 900 meters below the surface, with some populations recorded as deep as 1,200 meters. There exists a layer of ocean where dissolved oxygen levels drop to around 3 to 6% of surface saturation. 3 to 6%. The water here is not technically anoxic, it still contains some oxygen, but it contains so little that the vast majority of ocean predators cannot function here. Most fish require oxygen levels far higher than this zone provides. Most cephalopods, squid, octopus require more oxygen than this zone provides. Most things that would eat a vampire squid cannot breathe well enough to stay here. The vampire squid not only survives in this zone, it has made it home. Specifically, deliberately, permanently home. Its blood contains a specialized protein called hemocyanin, a copper-based oxygen carrier, distinct from the iron-based hemoglobin in human blood that has been adapted to bind oxygen with extraordinary efficiency at very low concentrations. It extracts usable oxygen from water that would functionally suffocate almost any other complex animal. And because almost nothing else can survive in the oxygen minimum zone at its preferred depth, the vampire squid lives in a predator-free environment. Not through speed, not through camouflage, not through armor or venom, through chemistry. It evolved the ability to breathe in a place where its predators cannot, and it has been living there largely undisturbed for hundreds of millions of years. That is not luck. That is one of the most elegant survival strategies in the history of animal life. Now the body itself. Because the vampire squid's physical features are not random. Every single one is a precisely calibrated solution to the specific challenges of its environment. Start with the eyes. The vampire squid reaches approximately 30 centimeters in body length, about the size of a football. Its eyes measure approximately 5 centimeters in diameter. On a 30-centimeter animal, that is a significant proportion. But the comparison that genuinely puts this in perspective is this. If that eye-to-body ratio were scaled to a human being, our eyes would be approximately the size of a large orange each. Those eyes, proportionally the largest of any animal relative to body size, serve one specific function: detecting bioluminescence in near total darkness. At 600 to 900 meters, the only light that exists is produced by living organisms. Cold, brief, rare. The vampire squid's massive eyes can detect those faint biological flashes across distances that allow it to assess its environment, predator, prey, other vampire squid, without producing any light of its own that might reveal its position. Then the cloak. The 8 arms are connected by a dark webbed membrane, the cloak that gives the animal its characteristic silhouette. The inner surface of this cloak, facing the body, is covered in small fleshy spines called cirri. When threatened, the vampire squid does something that no squid and no octopus does. It inverts. The cloak flips inside out, turning the animal into a spiky, irregular, dark mass that bears no resemblance to anything a predator's visual system might categorize as edible prey. It does not flee. It does not fight. It becomes unrecognizable. In darkness, where recognition is already difficult, becoming an unrecognizable shape is functionally the same as becoming invisible. Then the skin. The vampire squid's mantle, its body is covered in photophores, light-producing organs, but not arranged for display or communication in the way bioluminescence is typically used. The photophores on the vampire squid's body can produce a diffuse glow across the entire mantle surface, making the animal appear to dissolve into the faint ambient light at its depth, rather than standing out against it. Passive, controlled, efficient, and around the tips of its arms, concentrated photophores that can produce bright, brief flashes. When threatened and after inverting into its defensive posture, the vampire squid can produce those bright tip flashes to confuse and disorient whatever is approaching. A disorienting light show from the tips of a spiky dark mass in near total darkness. At 800 meters, designed by 300 million years of evolutionary pressure. For most of the 20th century, scientists assumed the vampire squid was a predator. The name, the teeth-like spines, the dark appearance, the deep water habitat, everything about it suggested something that hunted. Then in 2012, researchers at the Monterey Bay Aquarium Research Institute published a study that completely overturned that assumption. The vampire squid does not hunt, it eats marine snow. Marine snow, for those unfamiliar, is the continuous shower of organic particles that drifts down from productive surface waters above. Dead plankton, fecal pellets, shed exoskeletons, fragments of decayed organisms. By the time this material reaches 600 to 900 meters, it has been falling and partially decomposing for days to weeks. It is nutritionally dilute, sparse, widely dispersed, and the vampire squid feeds on it. Specifically, it uses 2 long retractile filaments, the structures that originally confused taxonomists, to collect marine snow particles from the water column. These filaments can extend to lengths several times the body length of the animal. They are coated in tiny hairs and mucus that trap particles as the filament drifts through the water. The vampire squid then pulls the filament back, runs it through its arms, and consumes the collected particles as a compact mucus-bound food ball. A marine snow burrito, assembled in darkness at 800 meters, by something called the Vampire Squid From Hell. This feeding strategy, called detritivary, is extraordinary for a cephalopod. Squid hunt, octopuses hunt, active, fast, metabolically expensive hunting. The vampire squid, in an environment where food is sparse and oxygen is scarce, abandoned hunting entirely. It became a slow, patient, passive collector of whatever falls from above. And this strategy is possible only in the oxygen minimum zone, where no fast-moving, active predators can enter to compete with or eat it. The vampire squid created a private cafeteria. By moving into a neighborhood nobody else could breathe in, and then it just waited for lunch to fall from the sky. For hundreds of millions of years. Despite living in a predator-reduced zone, the vampire squid is not entirely without threats. Certain deep-diving predators, sperm whales, some species of deep-diving fish, certain seals can reach its depth. And for those rare occasions when something actually gets close enough to threaten, the vampire squid has a response system that works on multiple simultaneous levels. Level 1 ink. Except the vampire squid does not produce ink. It produces bioluminescent mucus. When threatened, glands near the arm tips release a cloud of sticky glowing mucus into the water. This glowing cloud, cold blue-green, luminescent, drifting, hangs in the dark water where the animal just was. The predator's attention goes to the glowing cloud. The vampire squid is already gone. Not fleeing at speed, it cannot move fast enough for speed to be the strategy. Gone into darkness while the predator investigates something that glows. Level 2 inversion. We described this already, but the timing matters. The inversion happens simultaneously with the mucus release in some documented threat responses. The predator approaches a location, finds a glowing cloud, investigates. Nothing there. Somewhere nearby in the darkness, a spiky, irregular mass that looks like nothing edible is drifting quietly in the opposite direction. 2 simultaneous deceptions, operating in an environment where the predator already struggles with low oxygen. Level 3, the photophore display. If levels 1 and 2 fail, if something is still close enough to be a threat, the arm-tip photophores produce rapid, bright flashes. In near total darkness, a sudden bright flash is temporarily blinding to eyes adapted for extremely low light. A disorienting moment, a brief window, enough to disappear. 3 layered defense systems, each calibrated for darkness, each requiring no speed, no armor, no venom, just light, chemistry, and darkness. The vampire squid defends itself with the same environment it uses to feed and breathe. Everything it does with the dark. The vampire squid is not the largest creature in the deep ocean, not the most dangerous, not the most visually dramatic, but it represents something that I think deserves to be said clearly. It is a 300-million-year-old solution to a specific set of problems. Low oxygen, sparse food, rare predators, complete darkness, crushing pressure. And the solution it arrived at is by any objective measure extraordinary. Do not fight for oxygen, evolve blood chemistry that makes 3% saturation adequate. Do not compete for food, move into a zone where nothing else can eat, and collect whatever falls. Do not fight predators, make yourself unrecognizable, then release a glowing decoy, then vanish. Do not be fast, be invisible. Every single feature of this animal is a solution. Not a compromise, not a limitation, a solution. And the fact that it has been running this solution continuously, without significant structural revision for 300 million years, that is not stagnation, that is perfection. In engineering terms, when a design works well enough, that further revision produces no meaningful improvement, you stop revising. The vampire squid reached that point somewhere around 300 million years ago, and the deep ocean agreed. It is still there, still collecting marine snow at 800 meters, still inverting into a spiky dark mass when something approaches, still breathing in water that suffocates its predators, still named by professional scientists who studied it carefully and chose their words deliberately, Vampyroteuthis infernalis, the vampire squid from hell, not because they were being dramatic, because they were being honest. There is a version of this story that ends with something about how strange the ocean is, how unknown, how full of things we have not discovered. And all of that is true, but what I keep thinking about is what actually stays with me after spending time with the vampire squid is the name, because that name was chosen in 1903 by a careful scientist looking at something he could not categorize, something that did not fit any existing system, something that looked, in his own words, like nothing else he had encountered in decades of ocean research. And he named it honestly, Vampyroteuthis infernalis. Not to be sensational, because what else do you call something that lives in a permanent oxygen-depleted zone in complete darkness, eats particles that fall from the surface world like snow, defends itself with glowing clouds of mucus, inverts its own body inside out to become unrecognizable, has the largest eyes relative to body size of any living animal, and belongs to a taxonomic order with exactly one species itself that has been doing all of this continuously for 300 million years? You call it what it is, the vampire squid from hell, and you go home and you think about what else is down there that we have not found yet. If this is the kind of content that brings you back to this channel, you already know what to do. Subscribe, because there is so much more of this waiting. Every single word of it is true. Every single creature already out there, right now, in the dark.